We're going to start our This is How You Learn JavaScript. I do have some slides. The slides, I hope, are less than half of our overall presentation. So um, let's get into it. When I was thinking about the things that, and I made a list of the things that I feel like people don't understand in programming in general, but especially JavaScript, I think it occurred to me that inheritance is one of the concepts that is most confusing. So we're going to talk about that. And when I started thinking about why inheritance exists at all in the first place, it's because we don't want to rewrite code that we have already written. We want to share code. And so inheritance is a mechanism of allowing us to stay dry. If you haven't heard of this acronym, dry stands for don't repeat yourself. Whereas wet, the opposite, is write everything twice. And so if you are writing dry code, that is considered to be good. So that's where we're going to start. And so I'm going to give just a really brief explanation of what traditional class-based object orientation is. And so this is what it's like if you're programming in Java or PHP or Ruby or a lot of other languages use this. And then we're going to, once you understand this, we're going to get into the more JavaScript-y stuff. If you already know this stuff, then that's fine. It's really hard to gauge this type of talk and what kind of skill level everyone should be at. I think that the person who's going to get the most out of this talk is someone who's been learning JavaScript for about a month to about a year. So if you are still learning what a variable is or what a loop is, this conversation might be a little bit over your head. If you've been doing programming for 5 years, then this is going to be a little bit too easy for you. So, but if you are coming to JavaScript from another language and JavaScript seems to be confusing, this talk is going to make a lot of sense as to why it is confusing. So in other languages, when you want to make objects, objects are just a way of kind of encapsulating data and functionality all into one thing. So if you have an object that's a person, you have all the person's information, and you want to be able to do stuff to the person, right? You want to be able to update their name, delete the person, add more attributes to the person. So that's what an object is. And in many languages, what you do is you define these kind of like, I'll call them plans. They're plans for what your objects are going to be. And we call those plans classes. In a sense, they're kind of like templates. So you might write a plan for what it means to be a dog and a plan for what it means to be a cat. And then you realize that there's some code duplication because cats and dogs have a lot of the same characteristics. And I hope that sound doesn't continue all night long. And so what you might do is you might make an animal class and you extend the animal class from dog. So when you go to make a dog object like Max, the dog object is kind of a blend between the class of dog and animal. And so it has all the qualities of both of those. And then you can make a cat object that is the blend of cat and animal. So that way you can keep your code really dry. Okay? So inheritance is the concept of these, in this case at least, is the concept of these plans that you have inheriting their qualities from other more abstract plans. And so you can have dog that is an animal, that is a living thing. And actually, I want to talk about that is a relationship because we're going to talk about other types of relationships that are not is a, but this is the traditional is a relationship. And we're going to talk about maybe why some people think that's flawed. And so our next slide, I just wanted to show you here that we've got more plans, more things that inherit from more things with class-based languages. And I'm probably not going to do one of those hand polls where we say, oh, who's programmed in one of these like Java or whatever, because most people don't raise their hands anyway. But for those of you who have programmed in this, when you do class-based programming languages, the criticism there is that you almost have to figure out the whole plan before your application is really fully built. So you start building the plan, and then your application starts getting more complex. And then as your application gets more complex, the plan that you had to design in the beginning doesn't fit the new business rules of the application, so the plan has to be redesigned. Has anyone ever experienced that with class-based languages? And not that the opposite of inheritance and the opposite of this things like completely solve that problem, but that's one of the criticisms. So also there's this concept in programming called multiple inheritance, which basically means that if you wanted to program things this way, this is kind of considered like an anti-pattern by a lot of people. But if something inherits qualities from two other classes, then just so you know, that's called multiple inheritance and sometimes considered bad practice. Okay, so in JavaScript though, JavaScript has objects. JavaScript just doesn't have the plans before you make the objects always. It does sometimes, but JavaScript doesn't have classes, and there's the asterisk at the bottom for anyone who knows that JavaScript just got classes, but we're going to talk about that in a second. But in general, JavaScript doesn't have classes. You just simply make objects, and that's why sometimes in JavaScript we call them object literals, because you literally get to make the object right now without having the class that instantiated the object. So, and JavaScript has something called prototypical inheritance. So they have inheritance. It's just not class-based inheritance where you design these classes ahead of time, the plan. Instead, an object inherits qualities from another object. And then that object can inherit qualities from another object. So there's really no classes that kind of create the objects. There's just objects that inherit from other objects. So one of the qualities that JavaScript has because of that is when you have a plan, when you have class-based languages and you make an object, you cannot add more methods to that object. Methods are the functionality that you can do on objects, right? You can't add methods and properties to objects when the object has already been created in many languages. But you can in JavaScript. JavaScript, you can augment the object in real time. And Joe and Kevin, you guys can pipe in anytime you want if I say something that's a little weird. Okay, so prototypical inheritance does not have classes. You just simply have objects. So we have two objects here, Max and Chew, two different dogs. And basically, you could say that Max has a prototype chain where it's linked to dog, and dog has a prototype chain where it's linked to animal. But dog is an object all into itself, and animal is an object all into itself. That's a lot different than when you have class-based languages where those plans were just used to make Max the end result object. Hopefully this is making some sense. Okay, so in JavaScript, objects can be augmented on the fly, meaning you can add, remove all these things, all their properties in real time or runtime as the program is running. This is not normal. We kind of talked about this. So this makes JavaScript what? Dangerous, crazy, powerful, special. Yeah. I picked expressive. To me, and I haven't programmed in a ton of languages like some people, but I feel like after programming for many years now, I feel like I have an idea of how a lot of the other programming languages work at a high level because of just having lots of conversations. But I feel like JavaScript and some of the languages that JavaScript mimics are very, very expressive. When I look at like what the PHP community is doing or what they had been doing for 10 years and what the Java community has been doing, you know, everything they have is all inheritance-based. It's all MVC-based. And yes, one MVC framework is a little bit different from the next MVC framework. And to a PHP developer, they might seem like they're drastically different, but you haven't seen different frameworks until you've seen JavaScript frameworks. They are massively different. And the reason why one JavaScript framework to the next JavaScript framework is so different is because of how expressive JavaScript is. They really let you do many, many things, or the same thing many different ways. Okay, so if you guys have any questions, just speak up. I don't know, unless you guys are asking questions, if I'm going too fast or too slow. So inheritance in JavaScript, you have prototypical inheritance, or in class-based languages, you have class-based inheritance. There is a crowd of people that would say inheritance of any kind is generally an anti-pattern. And I'm not necessarily saying that right now. I'm mostly just trying to give you guys a lay of the land. There are people who feel like when you design things with a relationship, so this cat is an animal and the animal is whatever I said, living creature. When you design things with that tree-like hierarchy of stuff, you end up programming yourself into a corner where you actually feel like you need that multiple inheritance concept because you feel like cat is a this, but it also needs to be a that. And when you think in that is a relationship, you end up feeling like multiple inheritance is a good idea. Is that how you maybe felt when you were learning this stuff? Like it kind of when you're trained, and we were all trained if you went to school for this stuff. If you were trained in multiple inheritance, at some point, or I'm sorry, if you're trained in what was I saying? Classical inheritance, multiple inheritance starts to seem like a fair idea. I feel like, but it has been shown time and time again that it's not. In fact, anyone do React in here for a while? Has anyone been doing React so long they remember when mixins were a concept for React? Okay. Do you notice how they got rid of them? That's because mixins in React were a flavor of multiple inheritance, and they were deemed by the great people in React to be an anti-pattern. So there's an example of that. All right. So since we can have objects based on this other objects, we can think of things a little bit differently. We can start to think of things in terms of a has a relationship or a can relationship. They're kind of the same thing. So what if we could build objects based on what they can do instead of what they are? And if you do that, you're going to start to learn about this new idea, not new, but actually composition is definitely not new. It's been around for a long time. But I would say that this contrasting of inheritance and composition is starting to become a lot more mainstream. A lot more people are starting to talk about it. At least that's how it feels to me in the last couple of years. And so this is a better way to do it. I am leaving this very vague right now because if I started talking about composition, I would probably stumble over my feet a little bit and we would be here all night long. So if you want to learn more, there's lots of great YouTube videos. This guy right here who does the FUNFUNFUNCTION YouTube stuff, he's got this pretty interesting video. And then you should read all the comments where a bunch of people say he's full of shit. And then a bunch of other people say, no, you're full of shit. And then you're going to start to pick up on this thing called the composition over inheritance or inheritance over composition type of conversation. You know that expression, you don't know what you don't know? When you're first learning programming, and this talk is supposed to be about how to learn JavaScript, you don't know what you don't know when you're starting to learn programming. And so you don't know what to go learn. If you wanted to learn programming, what do you go and look up if you don't even know the keywords to go and look up? You see what I'm saying? So after you pass the phase of I don't even know what I don't know, you go to a few meetups like this one and you find out there's stuff I don't know. And I don't know what it is, but I know that there's stuff that I don't know. And now I can go look up inheritance and composition because I don't know those things. And that's the next step in learning. So that's what this meetup is about. So the fundamentals. We've had a lot of boot camp students who come to the boot camp and all they want to do is slam dunk in programming. They want to make the app and they want to get there as fast as possible. And I kind of learned programming, and so did Joe and Kevin, before the age of the lynda.coms, the codeacademies.coms, and all those things. So we learned a different way than maybe some other people are learning. But do I need to change this? Is it too distracting? Yeah. Okay, so I have seen those websites, but I didn't learn from those websites. And from what I've seen, it does seem like they want to get you to slam dunk as fast as possible, and they don't go through the fundamentals. And, I'll be honest, in the boot camp that we taught, we slowed the student down a little bit from going into wanting to slam dunk, right? But at the same time, we didn't have time to teach scope as well as we wanted to, or inheritance in general. There's a lot of concepts we didn't have time to teach. Because if we taught those things, we would have to not teach CSS, and then their projects would look like disasters at the end. So, and teaching them CSS maybe helped that a little bit. So, anyway, we need to learn the fundamentals, and so that's what we're going to get into here. But before I talk about this little list of things that we're going to talk about, this is kind of how I think of programming languages. So we have class-based objects versus non-class-based objects. And we have a bunch of languages. These aren't all of them. There's a lot more languages I could put up here, but they all kind of, if I put more languages up here, they kind of start to end up in between lines. So these were the more obvious ones to me. There's a lot of languages that were inspired by C++, like Java was inspired by C++, and then PHP was inspired by Java and other languages. And then there's languages that their syntax is just kind of like their own thing. They kind of said, you know what, we're going to make something that's not like any other syntax. And so they're not inspired by C++. But notice that all these languages are class-based objects. So when you're learning programming, if you come from, let's say, Java, and you're like, okay, I looked at JavaScript and it looks almost the same. Or I learned PHP and I looked at JavaScript and an if statement in JavaScript looks just like an if statement in whatever language I have in the upper left here. But then you start learning programming in JavaScript and you realize JavaScript works a lot differently. And so when it comes down to picking a programming language for a boot camp, this is what I always show people, because a lot of people have to ask me for when they want to start boot camp, what should we teach? There's really no good answer to teach something, because I know there's some boot camp students here taking the Ruby class, right? And they might be here in the room. And if you learn Ruby, you're learning a syntax that's very unique. It's not like C++, and it's class-based, and so it's not like JavaScript. And so that's going to be especially hard, I think. Maybe that's me just spitting stuff out, but anyways, that's kind of how I think of it. So JavaScript is its own animal, and that's because JavaScript, I don't know if you know the backstory, but JavaScript was created in 10 days by a person who didn't even really want to create it. Netscape had to basically beg Brandon Ike to come and work for them to make this language, and he said no like 100 times. And then they basically said, okay, well, I guess we got to go talk to Sun Microsystems. And so they invited Sun over, and Sun was working on this language for the front end. It was going to be based on Java. And then Brandon finally said yes, and he said, great, come work for us. And then as soon as he became an employee, they said, by the way, we're also working with Sun to make this language. So maybe you can put something together for us as a prototype. So he put together this prototype language. He called it like Live Oak or something. And they said it's got to look like Java. People won't like it if it doesn't look like Java. So he made it look like Java, but he did not want it to feel like Java. He wanted it to be like other languages that he respected, which are not like Java. And so he did what the boss said. He made it look like Java, but he made it feel like other languages. And they basically said, oh, this is cool. And they got in a big boardroom argument conversation, I can imagine. They're like, oh, let's call it JavaScript. And he's like, what? Like, I don't want to call it JavaScript, but it stuck. Anyways, there's this whole story. I can go on forever on that. But that's why it's called JavaScript. It looks like Java. It is nothing like Java at all. Okay, so I made this list today, and I feel like all the stuff that these are all the fundamentals. Everything on this whole list are the fundamentals that I think that someone should at least be familiar with before they start to pick up frameworks. So if you're trying to learn JavaScript and you're like, I'm going to go and take a React class, you are already surpassing all of these kinds of things. So you got to learn the fundamentals first. But if you go to the Code Academies of the world and the lynda.coms of the world, you're going to learn all the stuff in gray. And I feel like the stuff in black is the stuff that no one really teaches very well. And you should learn all those things that are in bold and black before you learn all the things that are in gray. And you should learn everything on the list before you start diving into something like React. React especially. Angular, you can maybe get away with not knowing some things. But that's because Angular has magic to it, which I'm not going to get into that conversation. But I'm not saying you have to learn all these things extremely well, and I see some of you taking pictures. So these slides will be available online, and also it's being recorded. So you can still take pictures if you like, but they will be available to you. So we're going to focus on the things that are here in the dark. And I tried making a list of resources, but every time I found a good resource that I liked, it was always Mozilla.org's resource. So if you're not familiar, Mozilla, in my opinion, is the hero of the web. The reason why we're not all marching to the Microsoft drum, all of us, is because Mozilla practically single-handedly saved us from having to do that in many ways. JavaScript, making JavaScript with Brandon Ike is one of them. And so they sit on the W3C board along with Microsoft and Google. And I think they're probably one of the more influential members of the W3C board. Maybe them and Google are pretty high up there. And so their stuff that they have here at this link, it is the factual stuff. It's not someone's blog where it's their opinion mixed in with the facts or whatever. Everything they say here is factual and good stuff. They got some really good stuff there. And I say that because now I'm going to show you something that maybe has been an opinion of a few people, but I think it's a fact. And that is JavaScript classes introduced in ECMAScript 2015, which is the new version of JavaScript, are syntactical sugar over JavaScript's existing prototype-based inheritance. That has been an argument, and all I'm saying is Mozilla agrees with me. So if you want to argue, you can argue with them. So JavaScript got classes And I think it was to appease. Here's what I think. People aren't going to like this, but I'll say it anyway. JavaScript is becoming so popular, and especially with Node, that Java and .NET developers are losing their jobs and or being required to switch to Node, and they don't like JavaScript, and so they're starting to be, let's just say squeaky wheel gets the grease. That's the nice way of saying it, and so they wanted classes. That's how I feel. You agree? You probably don't agree. No, he does. He wants to be more diplomatic. Mostly true. There we go. All right, so anyways, classes in JavaScript, they're syntax sugar. If you're not familiar with what syntax sugar is, you all know what Sass is or less is, right? When you write Sass or less, you're writing a nice sugary syntax that feels better, but what does that compile down to? It just compiles down in CSS. You can't do anything with Sass that you can't also do in CSS. It just makes it, it's syntax sugar, it makes it nicer to write. So when you write classes in JavaScript, under the hood, they're just going to map all the things that you did down to prototypes. That's all. So that also might be one of the reasons why classes in JavaScript feel a little bit inferior to the ones in Java and even in PHP, because they're never going to have all the features that those ones have, because at the end of the day, they're always going to be about prototypical inheritance. Okay, so I have a list here. Let's get into some real coding. I got a list here of stuff I wanted to talk about. And this is going to be slightly ad hoc because that's how I do the best types of lectures. I have done this same lecture for this little boot camp that's over here called Tech Talent South. I've done it for them twice, and it worked out really well. So I'm kind of familiar with what we need to talk about here. I'm going to go to JS bin, and if you're not familiar with these types of things, there's JS bin, there's CodePen.io, there's JS Fiddle. There's these places where you can just go and start typing code in, and they kind of give you a little starting point. Like this particular one gives you all the starting point HTML, and you just can start typing right into the body tag. Whereas CodePen, you just start typing right, and you don't even have to have an account. You just go there and you just say, I want to make something. As soon as you start typing right here, you're already in the body tag. They just say, don't worry about the body tag and all the meta stuff. We're going to do that for you. So they have different strategies, but the reason why I like doing JavaScript talks with JSBin is because I want to have access to the console and JavaScript, and I want everything else to go away. And sometimes with those other ones, they have the panels, and you got to like move them, and they don't move all the way over, and they don't give you the console tab. So this is nice for teaching this type of thing. So functions are functions the first thing we're getting into? Yep, functions. Okay, so functions are massively important in JavaScript, and I actually had this conversation with you two today in Slack about whether or not the things that I wanted to say were technically accurate. But has anyone heard of the term first-class citizen as a programming language? Okay, so functions are considered to be a first-class citizen of any particular language if they meet a certain list of criteria. It doesn't matter exactly what that list is right now. You can look it up. But we were talking about this, and technically PHP has advanced enough over the last 15 years where their functions meet those 4 criteria. And I'm thinking to myself, I don't really know if that's fair, and these guys will disagree with me. I was like, I don't really know if that's fair that PHP can call their functions first-class citizens, because they kind of added them as an afterthought, and PHP doesn't revolve around anything. PHP revolves around you can do whatever you want. But most people revolve their PHP around class-based, object-oriented inheritance. And functions are kind of like a second-class citizen in PHP usually. It's usually the objects that are the first-class citizens. Whereas in JavaScript, JavaScript has always revolved around functions as a first-class citizen. And if you want to make like an object, for instance, in JavaScript, you can make it from the template of a function instead of the template of a class. So you might be familiar with typing like, class person. Let me know if I need to make this bigger. Oh, that's a little too big. So you can say class person, and then you can define all these properties and methods and whatever. And you can say Dave equals new person. So this is pretty normal looking for Java or PHP or now JavaScript. And the class is the template. But I'm not going to do any ES6, at least not right now. If I did, I'd have to go down here and turn on the ES6 Babel compiler. So we're just going to do regular old JavaScript. If I said var person equals function, and we have a function here, I can now say var Dave equals new person, and if I console log Dave to see what it is, it's an object. Dave is an object now created from a person. So what are lines 1 through 3? Is that a function or is it more like a class? It's kind of both. Okay, it kind of depends on how you use it, and actually, it totally depends on how you use it. If I were to just say person like that, I'm using it like a function, and it's going to behave just like a function. But if you put the magical new word in front of it, JavaScript goes, okay, we're going to change the rules a little bit, and we're going to make an object out of the thing that gets returned from this. Did you guys know that happens? Some of you? Okay, good. So,
Brad,
yep.
I'm curious. I don't really know. What would happen if you just took out the word new right there?
Oh, you know. Okay, so if you call a function and the function does not return anything, then by default, JavaScript returns undefined. So a little tidbit of knowledge. So that's what happens. You knew that. All right, so you put this new word here, and now it's an object. Something I learned today from that book that I just showed you is that you can either return nothing in this case, and because we're invoking it with the new reserved word, makes it an object, or you could return an object, and it will actually, Dave will now be that object that gets returned, and not the person object. And I can prove that by saying, okay, Dave is a new person, and we can console log. We can say, hey, Dave, are you an instance of person? And we'll clear this and run it, and it is an instance of person. But if I return an object and run this, then we get false. So if you're familiar with what a factory pattern concept is, I didn't want to make this talk too much about patterns, but a factory is when you call a function and the function returns to you an object, and that function that you called is like a factory, and it can, based on the arguments you passed in the function, it can return to you different types of objects even. It's a pattern that gets used in programming sometimes. Anything else we should add to factory besides that? Nah. So in a sense, person is now kind of like a factory pattern, kind of, although we're kind of invoking it with new, so it kind of makes it a little strange. This would definitely confuse people that they probably don't see this up here. They probably just invoke your new person, and then they're wondering why it's not an instance of person. But it's possible in JavaScript. Just wanted to let you know.
So is that just the equivalent of not having the new there?
There might be a slightly objects in JavaScript are kind of funny how there's different ways to create them, and the different ways that you end up creating them end up making different qualities about them. And this is one of those deep JavaScript questions that honestly I forget, and I would have to go and look it up in that exact book. Do you know any different than that?
It is basically.
It's basically the same.
Like if you took out new again.
Yeah.
And just logged Dave, it should be.
Oh yeah, well that's because it's calling a function. Okay. So all right. So let's see something else that's. So can you already see now that I feel like it sucks that now we get to say PHP has first-class functions, because you know what, they can't do that shit. There's a lot of cool things you can do with functions in JavaScript, and PHP and Java and every other C++ based syntax language can't do. We're going to do all kinds of things with functions tonight, and you'll hopefully start to see that everything revolves around them. So actually, that's why, Roxy, when you were saying, oh, should I learn? I was like, you should probably learn a little bit about functions, right? Because if you were to tell an average person, go learn functions, they would go on Code Academy, and they would learn how to write out a function, how to pass it arguments, and how to return something, right? That's like the basic knowledge. So there's all kinds of things that make JavaScript a little bit different than that. So we're going to talk about two different ways to declare functions right now. One of them is you can say function and then a word, or you could say var foo equals function. And to some people who think that these are just simply two different ways to do the exact same thing, They're actually not the exact same thing. Does anyone know the difference or know what these two different ways are called? Yeah?
Well, I don't know what they're called, but it has to one hoists differently than the other.
Yeah, one hoists and the other one simply
Yeah.
doesn't hoist. So, so this right here is called a function declaration, and this one right here on the bottom is called a function expression. And basically what it comes down to is function declarations can do one thing that function expressions cannot do, and that's hoisting. I'll explain what that is. But function expressions can do many things that function declarations can't do. So in general, I kind of just default to function expressions. But hoisting, if you are not familiar, just simply means that if I were to console log, foo was called, in most languages, you have to declare the functions and then you call them. So if I call foo, let's clear this out and run it, we get foo is called. And if you were to try to call a function before that function exists, you would get an error. And it doesn't happen in JavaScript with functions that are like this, because what happens is JavaScript first runs through all the code and kind of checks things out for syntax reasons, and it hoists, in other words, it lifts up all of these function declarations up to the top of the code. It might be to the top of the scope.
Yes.
Yeah.
Okay, which in this case is the top of the code. Okay, so I wouldn't even know that because, again, I don't really do function declarations all that much. So that is hoisting. I mean, that's a typical interview question, at least that I would put out there, is do you know the difference between hoisting and not hoisting? Okay, so what else do we have on my list here? Functions are first-class citizens. They can be used to make objects. Okay, so this is probably the most important thing that I'm going to talk about next in terms of, where am I going? In terms of what functions do in JavaScript, different than other languages, is this is probably the most confusing thing to beginners, what I'm going to talk about now, which is scope. Let's get an honest show of hands, and we can close our eyes if you want so no one sees you. Let's get an honest show of hands. Do you know what scope is? Okay, so I want to say a little over half the room. What's that?
It's a pretty good Wim mouthwash.
Yeah, it's mouthwash. That's right. Let's move on. So scope in programming means when you make variables, what parts of the code can have access to and see those variables. That's what scope means in a general sense. So one of the things that makes JavaScript so different and so confusing is that they have a certain type of scope called lexical scope, whereas most languages have block scope. So lexical scope works like this. If I say var x equals 5, and let's say I have a function, so I'm going to do some function equals, do they have shortcuts? Yeah. Okay, so we have var x equals 5, and then we have this, and then we're going to call some function. So we're going to call that, and we're going to console log x. So if I clear this and run it, we get 5. And that's what's going on right now is functions have access to the variables that were created within the function, and they also have access to any variables that are created above them or on the outside of them. Okay, so x can break through this barrier, and it can get inside the function so that when we console log x here, we see it even though it was declared out here. However, variables cannot escape the function in that same way. So if I were to comment this out, and if I were to go and say var x equals, actually there's a caveat to what I was saying a second ago, but if I say var x equals 7, and then we console log x, okay, so we're going to call this function, it's going to console log out x, and then down here, if I were to console log x again, we get 7, and then we get not defined. So what's going on here is, if you're reading code for the first time, not the first time, but if you're new to reading code, when you see functions and you're looking at code and you're trying to figure out what's going on, just skip over the function because this function does not run on its own. This is really the first line of code that really has any meaning. So we call a function, so it goes back up here, we declare x is equal to 7, but variables in JavaScript, they're scoped to whatever function that they were made inside of. and any functions that happen to be inside of that. So if I made another function inside of this function, then it would have x, but x does not escape that function. I feel like I'm just rambling on at this point. Do you guys understand a little bit what I'm saying? Pretty good? Okay, so let's do some other interesting things. What if I did this? This is interesting. What do you think would happen? Think about it for a second. We should get 2 console logs because we're going to call the function which is going to do this console log. And then we're going to console log x again. Who thinks that we're going to get 7 twice? If you're like, I think so, no one else rose their hand, I'm not going to raise my hand. Right? Okay, so who thinks we're going to get 7 and then 5? Everyone. I should have done a blind hand raise on that one. So that's exactly what happens. We get 7 and then 5, and that's because even though this variable kind of, remember, breaks that boundaries and gets into this function right here, we've redeclared that variable, and the redeclaration of it ends up being a part of this scope here. So when we do our first console log, we get 7, and then down here when we want a console log, it's like it only wants to look at the scope it has access to, so we have the original 5. So what happens if I take that away? Then what are we going to get?
Undefined.
Let's try it out. So we get 7, 7 twice, and that's because when we first call some function, we obviously have this x right here, but this x is not making a brand new variable. It's actually accessing the scope that's out here, and it's reassigning it to 7. And so then we get 7 here, and then when we go in console log again, this x again was not declared in this function, so it doesn't belong to that scope, so it accesses the one out here. Okay. So in general, we always want to, we don't want to do that kind of thing. So always, use these words like var or the new ones like let or const, and we're going to talk about some of those too. So, okay. You guys have any questions about scope so far? Yep.
Actually, going back to that book that you mentioned, what was the name again?
JavaScript. What is it called?
Object-oriented.
Object-oriented JavaScript by Nicholas Zakos.
Thank you.
Okay.
So when you were talking about hoisting, right? So when the JavaScript file loads and you have function expression there, right? Do those get hoisted up?
No, they don't get hoisted up. That's expressions do not function expressions. What we have right here, when they're assigned to variables, which by the way is unique in programming languages, right? That's one of those 4 things that makes it first-class citizen. These ones do not get hoisted.
So they don't get
The declaration of the variable gets hoisted, but not the actual function.
So they get
Not the
set to
assigned
undefined
function.
functions.
What's that now?
Do they actually get set to undefined then?
But not if it's
No, the fact that it's not hoisted means that if I were to try to call sumfunc right there where the cursor is, you wouldn't see it. It's not there. It's like it's never been made. Yeah.
That's not really true.
No?
it's undefined.
Oh, because of what he said, where the variable gets hoisted, but the actual.
Definition is hoisted, but the value is not.
Yeah.
Well, it's not a
Define's
function. The bottom line is it's an error because it's not hoisted. Yep.
What are the aspects, the 4 aspects
The-
that make something a first class?
Let's see. If they can be anonymous, which I'm going to talk about here in a second. If they can be assigned to variables. If functions can be passed into functions, and if function can return functions. That's pretty much where we're going right now with this topic. Okay, so a lot of these things too, I was trying to think of like what order to talk about all these things, and I'm like, okay, callbacks, closure, this. There's really no good order to teach this, because in order to understand each one of these line items well, you have to understand the other ones kind of well. Like if I were to do an example on closure, you would need to know about scope. If I do an example on scope, you would need to know about functions. If I do one on functions, it's nice to know about anonymous functions. They all just kind of like lean on each other. So we're going to try to get through it, but I might bounce around. So bear with me. And if you guys think of any good examples, if anyone thinks of any good examples, we can talk about it. Okay, so back here to code. Can I get rid of this thing? No. It's kind of, and it doesn't let me click away from it. Oh, that's probably a little bit better, right? Is it too small now? It's like we got more real estate. but the menu's gone. Is it okay? Okay. All right. So what we're going to talk about now, I think what we should talk about now is anonymous functions. Yeah, let's talk about anonymous functions. Yeah, I think that's a good one. Okay. And that means we're going to talk about callbacks at the same time. Okay, so I would say besides scope, one of the other big things that people get tripped up on when they're learning JavaScript is asynchronous programming. In other languages, programming is synchronous. So what that means is if you had, let's say you made a PHP file and you did 5 things in that PHP file, and each thing is going to take about 1 second. The first thing that takes 1 second, the second thing has to like wait in line for the first thing to get done. So your overall program is going to take 5 seconds. That's a pretty long PHP program, but who knows what those 5 things are. Maybe they're talking to databases and doing all kinds of stuff. Asynchronous programming means that if you had 5 things that each took 1 second, the whole program is probably going to be done in 1 second because it's going to start all 5. It's going to start one and it's not going to wait for it to finish. It's going to move down to the next line of code and start the next one. It's not going to wait for that one to finish. It's going to keep on starting things until there's nothing else to start. And then when every one of those pieces of code finishes, they're going to return control back to JavaScript, and then JavaScript is going to do whatever else it needs to do. But the point is that there's kind of this like concurrency programming going on where multiple things can kind of be happening at the same time, which is not to be confused with multi-threaded, which I don't want to get into. I don't even know why I said that. Now I just opened up big diagrams. But JavaScript, one could argue, doesn't necessarily need to be multi-threaded because it has so many cool asynchronous concepts going on. Multi-threaded just basically means your computer and your software can think of more than one thing at one time. So anyways, let's do some asynchronous stuff. And I think the most obvious one is we're going to have this function. We'll say does lots of stuff. This is our function that we're going to call does lots of stuff. And it's going to take a little while. And I'm going to console log A here and console log B here, just to kind of show like the order of things that are happening. And then inside of here, we're just going to console log stuff. And so right now it's not doing lots of stuff. And right now it's also not asynchronous. What did I do? Yeah. Okay, so we get A, we get stuff, and then we get B. This is, I think, how programmers think when they're learning. They think in order, and it should happen in order, and they think synchronous programming, like things you program it in order, it should happen in order. But let's say this function needs to do something that's going to take a while. So to mimic that, I'm going to do a set timeout, which basically is going to run for 3 seconds. And when this function when this set timeout is done, they're going to call a function for us. And that function I'm going to do right here, I'm going to say we're done. And I'm going to console log. I keep on doing that because in my shortcuts I can do con tab and it makes me a console log. So we'll say, oops, what was that? We'll say done. And right here we're going to say we're done. So we're basically saying, hey, sleep for 3 seconds and then call this function right here. So we run this, A, B happen immediately, and then 3 seconds later we get done. So if you look at this, it seems like A should happen first. Then you call this function, and if you go in here, it says to do this instruction to call this. So you would think maybe can you see how a beginner might think that we're done ought to happen before B at the very end? But that's not what happens. Is anyone seeing asynchronous programming right now for the first time? A little bit. People are shaking their heads, and then they're like, "Oh, I ain't gonna admit that." Okay. Well, Roxy's seeing it for the first time. I know that, right? Yeah, see, you're my favorite student now. You should know that. So this is a callback function. What we're saying is this is one of those characteristics of a first-class functional language. We called set timeout, and we're passing in 2 arguments. One of the arguments is a reference point to another function. And so we're passing in this function, and we're saying when you're done doing whatever you need to do, call this function. So that's a callback function. Call me back when you're done. Okay. I guess you could think of it just like calling someone on the phone. If you had to call someone on the phone, and let's say it's the customer service person somewhere, and they're like, all right, well, I need to go do this thing. It's going to take me 5 minutes, so please wait on the line. And then you have to wait on the line. And then they come back and they go, okay, I'm done. And then finally you can put down the phone and go back to doing whatever you do at house. That's like synchronous programming. Asynchronous would be like if you call them up and they said, okay, this thing's going to take 5 minutes. I'll just call you back when it's done. And say, okay, fine, here's my phone number. Call me back. You put down the phone. You go and do some more work. The more work in this case is we moved on to doing B. And then they call us back with the phone number that we gave them. And that callback function is like that phone number. Fair enough? So this callback function happens to have a name. It's we're done. That's the name of the function. We can just call we're done down here if we wanted to. But what's the point of having a function with a name if its only point of existing at all is just in this one case, and we don't really need it anywhere else? Can you see why there's maybe no point in having more code where we got to declare it? And plus, naming things is hard, right? You guys have heard that expression, the 2 hardest things in programming. One of them is naming things. So the less things that we can name, the better. And so even though it might look awkward, if I were to replace, here's how I teach it to absolute beginners. I know that some of you aren't absolute beginners, but if I were to say var x equals 5, you could either, let's say this thing took a value, and we could either pass in x, right? That's the variable name. Or I could just pass in 5. The thing that's on the right-hand side of the equal sign, right? Either one passes in 5 there. Well, okay. So if we can do that in that case, then why can't I take the thing that's on the right-hand side of this equal sign, which is this function right there, and why can't I just put that, instead of passing in a variable, why don't I just put that right there? And that's how I teach beginners how to do callback functions that are anonymous. It's called an anonymous function because it doesn't have a reference point. It doesn't have a name like the other functions that we have.
Is that bad for debugging?
Yes, but you can apply a name into it right now. I don't do it, so I don't remember the syntax for it. I bet Joe knows, but I don't do the syntax for that. But you can apply a name to it and have it be inline at the same time, because it's really the inline thing that I really want. So
you can just drop the name right.
Yeah, I was assuming you would just drop a name like right there.
No.
It's function foo.
Yeah.
Okay, so does that make it technically a function declaration?
Yes.
Ooh.
Well, whatever the 2 are, I always forget.
Yeah.
But it's just a function like any other function, except now it has a name.
Yeah. Okay. So, anyways, I don't see a lot of code where they do that, and so you can say it's bad for debugging. But if you have a simple enough situation, a simple enough call stack, you can still debug just fine and figure out where it is, because it's going to tell you the line number. It kind of depends, I think, on your build tool and everything else. But I write it like this.
Eventually React.
What's that?
Eventually React.
Yeah. So anyway, also, if you're writing this stuff out for the first time, here's what I don't want you to do. I don't want you to do something like this where you say, okay, these are, by the way, I want you guys to meet the computer. This is not a typewriter. You can move your cursor around, and you don't have to type things in order. Here's what beginners do. Beginners, remember when you guys did this? And how many times did I rip on you guys for doing this? You would do this. You would do set timeout. You'd close that off, and then you'd start typing the function right here, function, and then you would, I don't know, do something like that, because you kind of forget the order of the characters. You break things because you think that you have to type it in the right order, and you don't. The first thing you should do is finish typing this, and then go back and type a function, and then use your left arrow and go like that, and that's how you do it. I know this might seem really silly and stupid to some of you who've been programming for a while. Every single student in our boot camp made that mistake for the first 2 weeks and drove me nuts. So this is something that beginners do, and so I think I should bring that up. It's not a typewriter. You don't have to go in exact order. Okay, so we've learned a few cool things. For one, we have functions inside of functions because we've got this does a lot of stuff. And then we call a function, we pass a function. There's a lot of things going on. There's anonymous functions going on here. We've got nested functions. We got callbacks going on. We got asynchronous concepts going on. All of those things are going on right now. Do you have a question? I saw. Scratch your head. Okay. Okay, so so that's basically that. I think we're getting close to 8 o'clock. Normally we go till about 8:30. So let's see.
I have a question, but
Sure. What's your question?
So if I wanted to make sure that the console.b happens after the does lots of stuff happens.
That's see when I'm thinking of this stuff at the house, I'm like, I'm gonna do that, but I don't take notes because I can't just read notes and just regurgitate stuff to you. But I'm like, I'm gonna have to remember that, and that's exactly what I was thinking. So let's say you did want B to happen when we're done. So I mean, technically, I could go up here and I could just program this to say B, right, Joe? There. That's kind of cheating. And the reason why that's cheating is because what Joe is saying is there's going to be this thing that takes a while, and we want something to happen when it's done. But chances are that thing that takes a while, it's going to be some sort of abstraction that we're going to want to reuse. And we might have a different thing that we want to be done when it's done, and not the same thing. And right now it's hard-coded to always say B. But I did solve your problem, right? Okay, so what if we did this? What if we said, you know what? It's going to call this function right now, and don't say anything, so I'm going to make it better, but this is what we'll do for now. What if I were to pass in a function right here? Like, just because, okay, set timeout is a built-in function in JavaScript, and a lot of built-in functions in JavaScript take callbacks. Did you ever think you can make your own thing that takes a callback? All you got to do is pass in a function. I can pass in a function right here, and we've just passed in something as the first argument of this thing. So that's going to end up right there, right? X is going to be our function right now. Just to prove it, I will comment out this stuff here, and we're going to say console log callback. So we're calling does lots of stuff. We're passing in a function. And up here, we've just received that function. That function is now called X. So I can actually call that function by doing that. X is a function. It's the name of a function. It happens to be the function that we passed in. I'm seeing some glazed eyes. And I know a glazed eye because I've seen them in the boot camp. So if you have any questions, I'm going to look down, but I know who you are. Any questions? No? Yeah?
So is this kind of the same concept of promises?
Not at all.
Not at all.
Promises
There's still
are a
asynchronous.
different way to solve the underlying problem, if that's what you're going for. But we might have time for that. Promises would be like the icing on the cake if we have time to get to it. Okay, so I'm going to clear this out. We're going to run it. We get A because that's obviously right here. We call this function does lots of stuff, which really doesn't do hardly anything. It just takes this argument X. It doesn't really know what X is. It just knows that we wanted to call it. I mean, if I pass in something that's not a function, like a string, I can try to do that, but we're going to get an error. So basically, this function that we're writing, it's kind of assuming, by virtue of seeing the parentheses here, that whatever we pass it is a function. I mean, I could give it a better name, I guess, but it doesn't have to have a better name. So what if then we go back to our code looking like this, where we say set timeout, which is going to call this callback function right here, and then we're going to call our function. So we're saying, hey, set timeout. After 3 seconds, you're going to call this anonymous function, and when that gets called, call this X, and that's going to say callback. So if I clear this and run it, A happens. 3 seconds later, we get callback. How does that feel? Does that feel warm and gooey?
Yeah.
A little bit? Okay. Well, let's talk about set timeout for a second. What does set timeout want us to pass as its first argument? A function. And what is X? Function. So I could maybe rewrite this, and could I let me ask you this: could I just do this right here? I'm tricking you now. Yeah, you can't do this because there's a big difference between passing around a function and calling a function. It's kind of like if I give Joe my phone number because he's hot stuff at the bar. What if he gives it to someone else? He didn't call it. He's just passing it off to someone. That person could pass it off to someone else. And before you know it, my phone number's on Craigslist. We all know where that goes. We've all had that night. No. But what I'm trying to say is there's a difference between passing a function around and then calling the function. So right now, what this would actually do is this is really, I don't know if I want to get how much into what this would do, but this would actually call X, and whatever X returns, it would pass that into set timeout. What does X return? X is this function. What does this return? Nothing. What happens when a function returns nothing? Undefined. So doing what I wrote here is the exact same thing as if I had done that. Okay? So that's why you can't call X, but calling it means you do that. Not calling it just means you don't do it. So if I pass an X, the function, into set timeout, now it works. I can clear it. I can run it. And it works. So what do you think the circumstances are that would be so that maybe I would just want to do it like I'm doing it right now, X, or maybe I want to do function like this and then call X like that? Is there a difference between them, you think? Or a circumstance that we might want to do this or the other one? Anything?
Other stuff.
What if you want to do other stuff, right? Yeah, what if you wanted to do whatever that is, and then you wanted to do X, right? Okay. Let me ask you this. What if you wanted to do foo, and then foo takes an argument, and then foo has a callback function, and then inside of foo you want to do bar, and bar does stuff, and then it has a callback function. This is what's known as several things. It's what's known as callback hell. What did you say?
It's starting to look like jQuery.
I've heard this being called something like the something Christmas tree or something because it eventually makes this like your code look all pointy. So that's one of the things that promises helps to solve is it allows you to do asynchronous things but without the deep nesting stuff. Although when most people are first learning promises, they still deeply nest things, not realizing there's another way you can do promises. So promises can be done poorly or well, and just because you're using promises does not mean you are avoiding problems. So, okay, so let's go back to simpler times. Good, thanks, Joe, for reminding me of that, because I think I read your mind as soon as you said, what about this? All right, so something else I want to talk about. Has anyone explored ES6 and arrow functions? A few people? You have? So let's talk about the this. It's not a variable. What is it? What is this? What is that called in programming?
It's called scope. But
Scope. Yeah. I'll call it a variable, but it's not a variable, so don't quote me on that. Keyword. Thanks. He's looking things up, I get. All right, just joking. So anyway, let's. Okay, so let's make some objects. Yeah, let's do this. We're gonna do some stuff here. So let's say var. I'm gonna do this, and I'm doing something wrong on purpose here. Not really wrong, but when you make a function, generally speaking, we use camel case in programming. But if you're gonna make a function that is basically used to construct objects, it's conventional to use uppercase letters at the beginning, just so you know. So now I can say whatever u equals new user, and we have ourselves an object. This is not all that much different from us just making an object literal, but I want to do this because this might feel more familiar if you're coming from classes. This is technically called a function constructor, and some people would argue with that, but Nicholas Zakos doesn't. I read it in his book 10 minutes before I started talking. Just want to make sure I was right. So anyways, just like when you make classes and one of your methods inside the class is the constructor, and what's the constructor, right? It's the method that gets called when you first instantiate the object. Well, there's no class per se, but this is the function that is being called when we instantiate this object, so they call it the constructor function. So I can say this dot name equals like name, and then we can pass in a name right here, and then I can pass in like Brad right here, and then I can even have methods like this dot say name equals a function, and we can say we'll just return. Actually, we'll return this dot name. So instead of calling this say name, we'll call it get name. All right, so then I can say u dot get name, which is going to return something to me, and I'm going to console log that, and hopefully this all works. Okay, so it works. So if you're not familiar with this, the term this refers to the object in context of what we're talking about here. So this function is kind of like a class in the sense that it is our template for making objects. So I can have, I can have the Brad object, and I can have the Dave object equals new user Dave, and then let's say I make the Brad object, and then I make the Dave object, and then I console log, Brad.getName. We run this, and it's still Brad, but if we change this to Dave, it's now Dave, and that's because we're not by calling this and passing in name, which gets assigned to this dot name. When we do Dave, you might look like we're overriding that variable this dot name, but we're not, because this is a template for making objects, and the this is contextualized for each one, so it allows each one to have like their own data. Does that make sense? Okay, so the this word.
So, Brad, what happens when you log just Dave? Calling the method?
If I log just Dave, I should get an error. What do I get the error? Oh, that's why. Yeah, you get an object. So, you wanted to just kind of like look inside the object and kind of see what the properties are. I was like, why do I get an error there? That shouldn't make an error. If you know what object literals are, where you just get to make an object with the square brackets, if you wanted to make two people objects and you made them with object literals, you would, and let's say each person object has a different name and a different age and whatever, but let's say they had different methods, like common methods, like they both have get name, they both have set age or whatever, you would have to repeat yourself over and over again, and that would be a big duplication of code. And so it would seem as though this allows you to have like almost like a templating system. It's actually, if you're familiar with classes, this is a lot like what a class is, right? Where it's like a template for making your objects, and that is true, except one little caveat in JavaScript is that if you do things this way, if you inside of this function, if I say this get name and I assign methods to it, every single copy of our person's objects are going to have in memory their own copy of that method. And so it kind of becomes a little bit of a memory problem. And so there are other ways to basically make methods onto this object. And you might do them by saying user.prototype.get name is a function. And so if you prototype on methods onto these, then actually that method is a shared asset between all the instances of the objects. And so there's all these little tiny little gotcha details of objects, and it all depends on how they're written and made, right? We were talking about that. And again, that book that I talked about, it kind of gets into all these things.
What specifically is prototype?
Well, remember prototypical inheritance. Remember we talked about that. So functions, this basically just, it's kind of hard to explain. It changed this method onto this function, or changed this function. It links them together in such a way that they know that they're related, and when we make new objects from them, it allows this function to be shared and not copied into memory over and over again, if that helps.
Would you say that's the main reason to use prototype right there?
No, I would say that there's a lot of complicated things in JavaScript, and when I program on a day-to-day or a week-to-week or a month-to-month basis, I mention the word prototype 0 times. Because, and I'll bet you do too, how often do you say prototype when you're coding?
When I'm coding, no.
Never. Same thing?
Now that I use class, I don't ever.
Okay. So, and the reason for that is because when I make tooling, and take a complex concept and I make a tool and make some nice little cute API for it, then I might use some of these really dense things that JavaScript has to make the tooling. But how often are we all making tooling and publishing them on NPM or whatever? Usually, the vast majority of us are consuming someone else's tool. We're using React, we're using Angular, and in that case, they're using all these kinds of concepts under the hood, but we get to use their nice API. So if you're going to learn JavaScript, though, like truly learn it, it's good to learn these things, even though in a practical sense, you're not using it any more than I know how to. I don't work on my car, but I kind of know how it works, right? And knowing how my car works kind of helps me out when I feel like it's breaking down, but I still am not going to work on it because I don't know how.
So what if you, instead of saying this.name equals name, what if you just scoped a new variable called name, like var name equals
Are you
name?
talking about like what if I said, because you
up in the function itself, yeah. Like
If
you
I
just did
said-
var name equals name instead of this.
Oh, okay. Well, then, I mean, if this were a regular function, then I would just make a variable scoped to that function. I think that would make a variable scoped to the constructor for the lifespan of the constructor doing the construction, and then I think it would just be forgotten. I think.
Okay, so it wouldn't. So when you do new user Brad or whatever, it's not.
Yeah, so I could make a name and I can like concatenate a string or whatever. But at some point when we get done with this constructor, it's just going to be like any other function where it gets kind of ignored forever.
Will that object exist with a user name?
No, it won't. You have to do like the this.name or whatever to attach it. Which actually brings me to another point. Let's just go back to this being a little bit more simple. And we'll go like this, and we'll go like this. So if we just simply have a little constructor function and we make a little object called Brad, you could do Brad.get name equals function. You could actually, in runtime, like I said, you can actually add methods and properties to this object in real time, and that's definitely not something you can do in like languages that are more class oriented, like Java, PHP, Python, Ruby. Okay, make sense? You probably already knew that, right? I'm talking to you. Okay, so I want to talk more about this. What's a good use case for I want to rename this to underscore this, but like I can do some jQuery real quick.
Or anything with a callback, really. If you have a function, you have to do it.
Yeah,
So you could write like an async.
but like the set timeout thing, you know, it has a this, but it wasn't useful for anything.
Yeah, but you could do like a set timeout that like logs the name or something. Right?
I'll tell you what. Why don't we? I know what I'm gonna do. We can go back to when this was this dot get name equals a function, and we're going to call Brad dot get name, and you know what? We're going to we're not going to pass in the name. Instead, we're going to pretend like this has to go to a database to get the name or something like that. So we call Brad.getName, and we don't really have a database. We don't have any AJAX stuff going on for this, but I'm going to do set timeout, where we wait for 3 seconds, and then we have a function that gets called. So that's kind of like when the database comes back to us, and then it's going to console log. Let's see. It's going to console log message plus Brad. Let's say Brad is like the thing that we got back, and message is actually something that exists right here, like this dot message equals hello. And so we're going to say this dot message. See where I'm going with that, Joe?
Yep.
Okay.
That works with name too. Yeah, that works.
Okay. Undefined Brad. Okay, so if I were to go like this and comment out everything that is related to set timeout and run this, we would get hello Brad, and that's because we call getName, and getName, when we use this inside of getName, we're talking about this being the object, right? So we said console log this.message, we're talking about this message up here. It says hello, and then we just say Brad or whatever, and that's why we get hello Brad. But why is it that simply introducing this code here completely breaks it? Anyone Have an idea? Yeah.
Yeah, isn't your this get name function that you're establishing, isn't it conflicting with the set timeout function because you're calling another function again?
I'll say it another way. Maybe that's right, but I had a hard time following that. But I think you might be on the right track.
Yeah.
What happens is this is contextualized to the nearest function, and so the term this actually belongs to this function instead of belonging to the overall object. And that's definitely something that people get confused with in programming. So so what can we do? Well, let's see. The old school way of fixing this is to, I mean, if I were to say this dot message out here, that says hello, but as soon as we use the term this inside of a function, it's like we've screwed up what this means. So what if I say, let's make a new variable called that equals this. And then I could say that dot message. And if I run it, it will work. I have seen some people use that, which is a little weird. What's a little bit more normal is to use underscore this. Have you ever seen that in people's code? So they're basically just kind of they're preserving what this means because this variable, remember how variables are lexically scoped, and so any variable that we make can get into functions that are in the same scope. So this variable is made in the same scope as this function, so therefore the underscore this can dive down in here, and then we can use it right there. However, if we switch this to ES6 Babel, we don't need to do that anymore because we can use arrow functions. And let me show you arrow functions. Arrow functions work just like functions, except they don't have the function word. You get rid of that. And then in between the parentheses and the first curly, you just do a fat arrow. And now it's the same function. And it works the same as a regular function, except for it has a different way that it scopes out this such that it doesn't, I forget how to say this, it doesn't have lexical scope, or it does have lexical scope. So it does have lexical scope, so it inherits the this from above it.
That's actually not entirely correct.
Okay, we'll say it a different way then.
Arrow functions actually do not have any scope.
Okay, they just don't have any scope at all.
So any scope that's above it happens to just be inherited by default.
Okay. Is that what you're going to say?
Same thing, but I worded it differently.
Okay. So that's why arrow functions are more than just a newer, fancier syntax. Because I think when they first came out, and I didn't really know that much about them, I think myself and a lot of people thought that's just programmers wanting to just write a few less characters, and it kind of looks a little more awkward. I don't think that's going to take on. But then I just realized that they actually operate a lot more differently.
Forgot how lazy programmers are too.
Yeah. Okay, so we've talked about block scope versus lexical scope, this nesting function, preserving this. That's what I was just going to talk about. Arrows. I think I left just enough time to talk about closures and maybe promises. And that's basically everything on the list. How do you guys feel about this so far? Has this been pretty good? Okay. I'm not going to ask you if you want to learn about closures. Why am I opening that up? Closures or promises, because if you don't know what they are, then you wouldn't know which one's more valuable, and I think closures are more valuable than promises. So that's what we're going to talk about. What? Well, you got to let me talk about it first. Okay.
Yeah, question.
Yeah. Are you using Sublime Text Editor to actually build your code, or do you prefer to do that in something like JSPen?
Oh, this is just for presentations.
Yeah, but I mean, like.
But in real life, I do Sublime.
Sublime.
Atom and Sublime are kind of becoming the de facto standards for editors. I just haven't had time to look at Atom enough, but I've heard that when it first came out, it was slow, and then I heard it got a lot faster, and then recently I heard someone say, no, it's not fast, it's slow. A lot of people at your office embrace it, so how do they like it?
Yeah, everybody I know that's tried Atom has really liked it.
Yeah.
What's
still
the
haven't either.
difference? Because I'm really familiar with Sublime, but I haven't touched Atom.
I haven't touched Atom because I'm also really familiar with Sublime.
They're essentially the same. The only real functional difference is Atom is completely JavaScript, whereas Sublime is
Everything.
Python or something else. So you can actually write extensions for Atom in JavaScript.
What he means, in case you heard him incorrectly, is Atom was written in JavaScript, but you can program a CSS file or a JavaScript file or a Python file or any kind of file. So what you said almost sounded like you were trying to say you can only do JavaScript in Atom, but that's not true. He's saying that you don't need to care about what Sublime or Atom is written in any more than you need to care about what Microsoft Word is written in. But because Atom was written in JavaScript, it tends to have libraries and plugins that integrate with Node and JavaScript a little bit better, I think. But because it's a web tool, it's just never going to be quite as fast as Sublime for a while anyway. Okay, so Clojure. I went to a meetup in LA once. I drove all the way to LA for a meetup. No, not really. I was driving to Northern California. I was going to spend the night in LA, and there happened to be a meetup, and it was on Clojures, and the whole thing ended up just being a commercial for this boot camp. And they spent the whole time talking about Clojures, and I think it can be more simply explained than the way that they did it. So the whole time I'm thinking, if I ever do a talk on Clojures, I'm going to do a little bit better. So Clojures are one of those things that when you're first learning them, you're going to have this relationship with Clojures where even after this talk, you'll probably be like, I still don't really understand Clojures. And then you'll go and learn it, and then at some point you'll be like, okay, I feel like I understand Clojures. And then you'll do some more stuff, and you're like, yep, I definitely don't understand Clojures. And then you'll eventually learn how to use them. It's one of those things, too, that when you first learn them, you're like, okay, that's interesting. I just don't know how I would ever use that. So I think maybe I can give you some examples, but at face value, I'm going to tell you technically how a Clojure works, and then I might actually have these guys help me think of an idea for when to use Clojures, because I know when to use them in real context. Sometimes it's hard to come up with like a contrived example for like example purposes. So let's say I make a function. We will call it whatever, it doesn't matter, do something, and that is a function, and this function is going to return a function. And remember we said that one of the qualities of first class functions in a language is that they can be passed functions, like we were passing them as arguments when we were doing callbacks, right? And another quality is you have to be able to return a function. So here we are returning a function, happens to be an anonymous function. And ordinarily, if I were to make var x equal 5 right here, ordinarily when we call do something, it would do whatever it needs to do, and it would return control over to the whatever called it, and all the internal variables would be cleared out of memory, right? But the way Clojures work is we're returning a function. So calling do something actually gives me, we'll just say returned function. These are really bad names perhaps, but the names say exactly what they do. So we're going to call this function here, we're just going to return a function, and then we're assigning that function to this thing called return function, which we can now call. So I can call returns function, and this is going to console.log. Okay, so it works. All right, do you guys understand the mechanics of it so far? Bless you. You guys understand the mechanics of it so far? So if this, now normally under normal circumstances, like I said, if you just like returned, I don't know, like a string or something, x is forgotten about. But if we return a function, and this function, maybe we pass in a number into it, and that number we're going to call n, and maybe it wants to, we will return n plus x. So what's going on here? We're going to pass in 7. So this function that we got back, we're going to pass in 7, and when we call it, it's going to pass us back our 7 plus x. But how could it remember x when x was like from the previous call, right? It does remember it, and that's what Clojure is. So that's the best I know how to explain it. So we run this. Why isn't it not working? Oh, it's because we're returning it, and I'm not like console logging it out. So that's Clojure. The fact that a function can return a function, and the returned function still has access to the scope of the outer function. That's my definition of Clojure. I'll let these guys say anything else they want to say.
Well, it might be important to point out that, I don't know what line numbers it is, the last 2 lines. Between those 2 lines, do something has completely executed.
Down here, where the cursor is? Those 2
The
lines?
last 2 lines.
down here.
Yeah.
Okay.
So like do something, that function is completely executed at that point. Like it's not waiting, like with the set timeout thing, it's not
Yeah.
waiting for something to happen. It's done.
Yeah.
And under normal circumstances, that's when it would get garbage collected.
Yeah.
But return function still has access to it.
Yeah. So I can think of one. I can think of one actual really good example that I used functions or rather closures, and it was for an API. I'm not going to get into the details of the API. What's that?
Before you blow this away, I have 2 follow-up questions to it, but you keep going. I just don't want you to lose this code.
You want me to lose this code?
Yeah.
Okay, I'll just make a brand new JS bin. You want to just talk about what you want to talk about?
I had 2 questions about what you had.
Well, then let's talk about it.
I think other people might also have.
Well, while we're here, let's talk about it.
So, one, is there a way to access the value of x from the do something from the return function?
From the do something, I don't know what you mean.
So without calling the function that we got back from do something, is there a way from outside of that scope to access the value of x?
The only way I can think of it would be to make it a global function or a global or to do that.
Right.
So is that your question?
The answer is no, but yeah.
So the answer is no, but yeah.
No. That would work, but the answer, the way you
The
have
way
it-
it's written, the answer is no.
Yeah.
Correct.
And then the second question is, if in the function that you're returning, if you somehow change the value, or could you somehow change the value of x?
Probably. No? Yeah?
Definitely.
Okay. All right. I've never needed to do that. And you know what? I just realized instead of doing that contrived example, I'm going to do revealing module pattern so they learn a pattern and closure at the same time.
Yeah, the reveal module pattern would work really well here.
Okay.
And is the 12 from the previous exercise, or is that from this?
No, that's for this right now.
Okay,
That's this code. If I clear this out and run it.
Took out the lines.
Oh, did I delete a line? What
Okay.
oh yeah. So I need to.
Where the 7 went, yeah.
Okay, so you understand if I put that line in, it works. Okay. So yeah, once people start to feel like they understand functions and they understand scope, closure kind of blows their mind because it kind of defies your understanding of the rules that you've grown up on in programming. So I'm going to teach you. Can we throw this away? I'm going to teach you this pattern that someone came up with. I can guess, but I might guess wrong. So it's called revealing module pattern, and so do you remember when we were making like the thing that looked like a class, or even if you use ESX classes, you notice how there's no like private or public? You notice that? Okay. Or when I made my function, it had like this.name, like it wasn't private or public. Like I made a method so I can access it, but we could have just accessed the property without the method. Do you understand that? Because it was all public. So is there such a thing as private and public in JavaScript?
No.
Not officially, but there's ways to virtually make that happen. And revealing module pattern is one of them. And so, so if I were to, oh boy, how long has it been since I've made one of these? Okay. Is a function, is it a function that we start off with? I know it returns an object. Yeah, I think so. Okay, so let's say I had, var name equal to Brad, and this is going to be like, I want this to be private, right? So I don't want the outside world to be able to see this, and so if this function returns, this is basically just going back into the exact same examples I had before.
So you can give that function a name. So basically assign it to like get name or something.
And then return get name.
Return objects.
Oh, that's right. Okay, I'm remembering now. So if we return an object, so that when we call some module, we're going to get an object back, and so that we can do, I'm just going to call this module, and we can do module dot. I want to be able to do module dot something. It's an object, right? Like I call a function, I want to get an object back, and so we're going to return this object. This object is going to make a method, or yeah, a property called getName, which is basically equal to getName. This one right here, and then this one will. Am I doing this right? Return name, and so this object that we're going to return. This object will have methods that we can access, but we can't actually access name directly anymore. So I don't know if this is making any sense, but I can say module.getName like this, which is going to return the name. So let's console log that out. Clear, run, we get Brad, but notice that I can't do module.name because after all, what is the thing I'm returning to us? I'm returning an object. Do you see name as one of the properties? It's not even there, and this is only possible because of closure. So it's like we've got this thing, this getName, which is a function that would ordinarily be forgotten, but because we're technically returning a reference point to that function, that reference point has a remembrance of its earlier values. So that's closure in practice, one of the ways you can do it. Another way, maybe I'll just explain this, but another way that I've used it is where there was this API and they want me to pass them a function, not call a function, but pass them to the name of a function, and then they're going to call that later on. But I wanted to pass them a function and give them some kind of circumstantial data. So I would pass in a anonymous function, have my data as a part of that function, and then call or then return a function for them to call, and it still had access to the data I passed in. I don't know if that made any sense in your head, but I think it would take us a little while to get into that. So I don't know how much time we have for promises, unless you guys really wanted to stick around, but that was pretty much, I think, everything I wanted to talk about. This is also something that's pretty cool that would be pretty easy. So I don't know, do you guys want to learn something more for 5 more minutes, or do you want to bounce out because it's getting kind of late?
I just have a quick question on Kirby had.
Sure.
So based on the scope chain, right? You're not technically you wouldn't even be able to access the name variable, like just search variables in general. Right?
I wouldn't be able to access name variable,
You
then
wouldn't
what?
be able to access anything inside a function because of like.
Yeah, because we called function, but function returned to us an object, and so
If you didn't return the object and you just had a function.
what would I return?
Just like say, I don't know, text or something like the string.
Yeah, if I just returned a non-object or a non-function or nothing, then I guess, yeah, it would just kind of completely forget about all that stuff that's inside of that. As a part of garbage collection, just to kind of clean up memory. Because imagine you had a function that made a variable inside of it, and you called that function like 10,000 times because it's in a loop. You wouldn't want 10,000 variables being racked up in your memory.
If you use getName on this, like mod.getName, could you change the variable name? Like mod.getName equals Dave.
Yeah, so if I did, and that's what he was talking about, where you can change the variable. So if I wanted to do set name is equal to, and you know what, right here, I guess I could make a method up here just called set name, or I mean I could do this, right? I mean I'm sure that would work the same. So I can say, in this case, name. How would that work?
You gotta pass something in.
Yeah, so I can't do this because this would override, like right now without that there, name is referenced to this guy up here, but if we pass in name, it would override that. So I'm going to call it n, so I can say name equals n. So down here we can say mod.set name is Dave, and then I guess we would do our console.log for get name. Right? That's what you're talking about?
Yeah, I mean, I was asking about outside of the sum module function, but
I wonder why it's not
I was
doing anything.
wondering what happens when you assign something to getName.
Oh, it's because I don't have a comma right there. So you were asking what now?
that kind of answers it. I guess I was just asking a different one. Like if you did without putting in the set name in the object, if you just had getName equals getName, and then you did like you did before, return, and you went down. and then you had mod.getName equals Brad, can you access the name variable by doing mod.getName and changing that variable?
Because the get name
Oh,
starts
yeah.
out as a function, but then it would be
Yeah.
replacing the
Yeah,
function
yeah,
as a
Yeah, you can override the function, but then now you just kind of like lock yourself out of the box.
Yeah, now you don't have access to anything.
Yeah, so
Cool.
that what the closure is doing is basically encapsulating that name variable or anything that's in there, and we are selectively revealing part of what's in that closure, right? We're selectively making get name and set name available. We are not making name available, but we are giving you access to other pieces that will give you that value.
And in a sense, it's kind of like having stuff be private and public, because the stuff that you return is everything you want to be public, but the public stuff has access to this stuff through closure that you don't want the outside world to have access to. So maybe that's not technically, by definition, a private feature of the language, but you just virtually do the same thing.
So if you knew the internal structure of this function, though, you could override any of those object.
If you had methods for them.
If you created a method that overwrote like some hidden variable that they didn't want exposed, but if you knew that there was a variable in there, you could write a function to replace some.
Yeah, but that's like saying,
You can't. I know what you're asking. You can't do that.
You can't do that.
No. So like if you had reassigned get name on the instance of mod, or the instance module of mod there, the scope of the function that you give it will be its own scope.
Oh, it changes scope.
Right. And like
Okay.
every time you use the function keyword, you get a new scope. So whatever function you assign to it would have its own scope. It would have no access to.
oh, you're talking about
closure.
replacing a function.
Right.
Yeah, okay, I understand now. Yeah,
replace
that
it. Yeah.
it would get its own scope.
Okay.
Yep. So, being that we want to do a little raffle real quick and probably hang out for a little bit, maybe the other stuff I was going to talk about is not even related to this stuff anyway, so maybe we'll just kind of call it a night. Let's do the raffle. Thank you.